Hello everyone, this is Dr. Madhusudan Rao and the program I teach medical students. The topic of today is fetal circulation. Fetal circulation is the circulatory system during fetal life. It contains, its components are the fetal heart and blood vessels, umbilical vessels, and the fetal-placental circulation. Well, during fetal life, the lungs are non-functional. And where is the gaseous exchange takes place? It is in the placenta, the gaseous exchange takes place. And fetus has to receive the adequate nutrients and the oxygen for the development of the rest of the organs. The circulatory system starts functioning even before its development is completed. And besides, it starts functioning to provide the nutrients and oxygen for the development of other organ systems. Okay. This is the importance of the fetal circulation, and the components we are talking about, the fetal heart and the blood vessels, they have specific features, certain features that are present during fetal life, which do not occur after birth. And the functionality of the fetal circulation and the oxygen saturation at the various levels of the fetal circulation are going to be discussed in this particular lesson. Coming to the fetal heart. Fetal heart starts developing around 4th week of intrauterine life as a tubular heart. This develops from the mesenchymal layer of the embryonal tissue. This tubular heart undergoes looping, followed by segmentation, and ultimately develops into a 4-chambered heart with 2 atria and 2 ventricles and 2 AV valves, that is tricuspid on the right side and the mitral on the left side, and the seminal valves at the base of the great vessels, that is aorta and the pulmonary trunk. Well, besides this, how the fetal heart differs from the heart after birth. Fetal heart. During the fetal life, right ventricle is the dominant ventricle because it pumps more than 55% of the total combined ventricular output, and it pumps the blood against the higher resistance. That is, pulmonary vascular resistance is higher during fetal life. So the right ventricular size is much more than the left ventricle, and its wall is thicker than the left ventricular wall. And when you take the ECG, right chest potential shows the higher potentialities rather than the left chest leads. Well, it is only the 15% of the right ventricular output goes into the pulmonary circulation. So the pulmonary arteries are smaller when compared to those in the adult after birth. So that is the reason why you will appreciate some amount of the systolic murmurs following birth. And coming to the other structures in the fetal heart, that is, you have a valvular opening that is called foramen ovale in the interatrial septum, which allows the flow of blood from the right ventricle into the left ventricle. So this foramen ovale is the fetal structure which is present in the interatrial septum. Well, it is formed by the ostium secundum of the septum primum and the lower margin of the that is the ostium primum of the septum secundum. This septum secundum works like a flap-like membrane, and so it allows the flow of blood from the right atrium into the left atrium. Okay, this is the foramen ovale. Then you have got the two important vascular structures during the fetal life. These are ductus arteriosus and ductus venosus. Ductus arteriosus is the vascular structure that connects the pulmonary trunk to the descending aorta. It allows the flow of blood from the pulmonary artery into the descending aorta because most of the right ventricular output goes into the aorta through the ductus arteriosus, which in turn supplies the blood to the trunk and the lower extremities. Well, other vascular structure that is there in the fetal life is ductus venosus. Ductus venosus is the vascular structure that connects the umbilical vein with the inferior vena cava. So the umbilical venous blood goes into the inferior vena cava before it is emptied into the right atrium. So these are the two important vascular structures during fetal life, and an important valvular opening, that is the foramen ovale, that exists in the fetal heart during fetal life. So this is the diagram showing the fetal circulation. You see the placenta. This is the placenta where the gaseous exchange takes place, and some nutrients and the other important elements are delivered to the fetus for its growth. After the blood getting oxygenated, it is taken to the this is the umbilical vein that carries the oxygenated blood, the pure blood from the placenta, runs in the umbilical cord along with the umbilical arteries and enters the fetal abdomen and is connected with the inferior vena cava through ductus venosus. Okay. This is the ductus venosus that gets connected with the inferior vena cava. Inferior vena cava drains the lower part of the body, takes the deoxygenated blood and gets mixed up with the oxygenated blood received from the placenta through the umbilical vein and empties into the right atrium. From the right atrium, the blood flows preferentially through the foramen ovale into the left atrium. So from the left atrium, blood is pumped into the left ventricle, and left ventricle ejects this oxygenated blood into the aorta. From the aorta, the brain, head and neck, and the upper extremities receives the better oxygenated blood from the great vessels that arise from the arch of the aorta. Okay. Then superior vena cava drains the head and neck and the upper extremities, and the deoxygenated blood is emptied into the right atrium, which flows through the tricuspid wall into the right ventricle. Right ventricle ejects the blood about more than 55% of the combined ventricular output is carried by the right ventricle, and it ejects the blood into the pulmonary trunk because of the high pulmonary vascular resistance. Most of the blood from the right ventricle ejected into the descending aorta through the ductus arteriosus. Okay. So this deoxygenated blood or poorly oxygenated blood and mixed blood enters the descending aorta, and The abdomen and the lower extremities receives the blood, that is mixed blood, from the descending aorta. Ultimately, it is pumped to the placenta via the umbilical arteries, which arise from the internal iliac arteries. So this is the fetal circulation that is represented in this particular diagram. These are the important structures that are there in the fetal circulation. In order to take the oxygenated blood from the placenta, and better oxygenated blood is supplied to the tissues in the head and neck and the upper extremities. And poorly oxygenated blood is supplied to the abdomen and the lower extremities. And ultimately goes to the placenta, to the umbilical arteries to get oxygenated. This is how the fetal circulation is represented in this particular diagram. Then coming to the discussion. As I told you, heart begins as a tubular structure with a double missing layer of the embryonic tissues. Begins as a tubular structure, undergoes grouping and segmentation, ultimately forms the fourth chamber. They cause the foramen ovale, that works like a valve, allowing the flow of blood from the right atrium into the left atrium. Ductus venosus is the vascular structure that connects the umbilical vein with the inferior vena cava. Ductus arteriosus is the vascular structure that connects the pulmonary trunk with the descending aorta. Okay. Well, during fetal life, right ventricle is the dominant ventricle. Its wall thickness is much more than the left ventricular wall. Well, as I told you, right ventricle is the dominant ventricle during fetal life. It handles nearly 55% of the combined ventricular output, hence its size is more than the left ventricle. If you take the ECG of the fetal heart, it shows higher potentials in the right chest waves. Then, from the right ventricular ejection fraction, pulmonary flow occurs around only 15% of the total ventricular outflow. And hence the size of the branches of the pulmonary arteries is small. Left ventricular output accounts for 45% of the combined ventricular output, and its function is against the low vascular resistance of the pulse in the circulation. So its chamber size and wall thickness is relatively less than the right ventricular wall thickness. Now, a point about the fetal hemoglobin. Fetal hemoglobin has got the configuration of 2 alpha chains and 2 gamma chains. It has got the higher affinity for the oxygen and gets saturated at the low oxygen content. So it is the molecule that is very important during fetal life because gaseous exchange takes place at the placenta where the oxygen content is much lesser than that in the alveoli of the lung. So in this hypoxic environment, fetal hemoglobin plays an important role to grasp more amount of oxygen and get saturated to 100%. And it is the molecule that plays an important role to carry the oxygen at the low oxygen content and getting fully saturated supplies the oxygen to the fetal tissues for their growth and development. This is the diagrammatic representation of the fetal circulation. So you have got the placenta here. From there, the better oxygenated blood is taken by the umbilical veins. It is empties connected with the inferior vena cava, where it is mixed with the impure blood. Okay, because inferior vena cava drains the blood from the lower extremities and the trunk, carries the deoxygenated blood. It gets mixed with the oxygenated blood of the umbilical vein, and its saturation falls down from 82% to the 67% in the inferior vena cava. And this inferior vena cava blood is pumped into the right atrium, which preferentially goes into the left atrium through foramen ovale. From there, as I told you, it is emptied into the left ventricle. And left ventricle ejects this higher, better oxygenated blood into the aorta. So the neck, head and neck and the upper extremities, thus they receive the blood of better oxygenated blood, whereas the lower extremities receives the oxygen of blood of poorly oxygenated blood with an oxygen saturation of around 58% only. Okay. This in turn is pumped to the placenta via the two umbilical arteries for the oxygenation. This is the representation of the fetal circulation in brief. This is similar to the picture I explained earlier. This is also similar to the fetal circulation which we have talked earlier. It's also the same. So what happens after birth? Following the first breath, there is fall in pulmonary vascular resistance, which is high during fetal life. Once the alveoli are open and blood vessels are exposed to the oxygen content, and there will be pulmonary vasodilatation and drastic sudden fall in the pulmonary vascular resistance. That results in the increased blood flow from the right ventricle into the pulmonary circulation, and there is increased venous return into the left atrium, and left atrial pressure rises. It results in the closure of the foramen ovale. This is functional closure of the foramen ovale. Rise in oxygen content, fall in prostaglandin levels because placenta is the source of prostaglandins. Once the placenta is removed, there is sudden fall in the prostaglandin level. This results in the closure of the ductus arteriosus. So, rise in systemic vascular resistance because aorta pumps the blood to the peripheral circulation. Okay, it is diverted from the placental circulation to the systemic circulation. So the circulation is altered from the low resistance placental circulation to the systemic circulation of the body. So it is so left ventricle is ejecting the blood against the higher resistance when compared to that in the fetal life. So there is rise in the peripheral vascular resistance. Okay, and the direction of flow in the ductus arteriosus from the right to left is prevented, and there is functional closure of the ductus arteriosus because of increase in the oxygen saturation and fall in the prostaglandin levels. Once the foramen ovale is closed and ductus arteriosus results in the ventricular output, right ventricular output flowing into the newly functional gaseous lungs of the gaseous exchange. So once the foramen ovale is closed, the blood that is flowing to left is prevented, and the right ventricle pumps its blood into the right atrium, pumps its blood into the right ventricle, and right ventricle instead of right ventricular outflow freely flows into the pulmonary circulation because of the falling pulmonary vascular resistance. So there is the gaseous exchange after birth takes place in the newly functional lungs, and there is increased venous return to the left atrium. So the vicious cycle goes on. This establishes a sort of continuous circulation rather than the parallel circulation that occurs in the fetal life. This is what happens during fetal life. So there is a right ventricular, right atrial blood is going through the foramen ovale into the left atrium, from the left atrium to the left ventricle, and from the right ventricle, blood is flowing through the ductus arteriosus into the descending aorta. Once the lungs are functional, pulmonary vascular resistance is dropped down. Most of the right ventricular output goes into the pulmonary circulation, and there is increase in venous rip into the left atrium. Left atrial pressure increases, and there is a closure of the foramen ovale, and there will be the establishment of the pulmonary and the systemic circulations after birth. This is what happens during fetal life. This is the echocardiogram of the fetal heart, showing the presence of foramen ovale, patent foramen ovale. Okay. This is the foramen ovale. Well, coming to the umbilical vessels. Well, umbilical vessels plays an important role for taking the blood to the placenta for the gaseous exchange and receiving the nutrients and other elements that are required for the growth of the fetus. You have one umbilical vein and two umbilical arteries. As I told you, umbilical vein begins in the placenta, continues in the umbilical cord along with the umbilical arteries into the fetal abdomen, and it gives rise to the vessel called ductus venosus, I told you, which connects the umbilical vein with the inferior vena cava. Right branch of the umbilical vein joins the portal vein to enter the right lobe of the liver. Inferior vena cava drains into the right atrium, and superior vena cava, bringing the blood from the head and neck and upper extremities, empties into the right atrium. Inferior vena cava blood, which is oxygenated, preferentially shunted from the right atrium into the left atrium through foramen ovale. Whereas superior vena cava blood flows directly into the right ventricle. Well, right ventricle pumps its contents into the pulmonary tract. From there, it flows into the descending aorta through the ductus arteriosus, thus bypassing the non-functional lungs. So, left atrium empties into the left ventricle, which in turn pumps its contents into the aorta. Well, internal carotid arteries gives rise to two umbilical arteries, which finally end supplying placenta. Okay. Coming to the fetoplacental unit. So it plays an important role during fetal life, not only for providing the gaseous exchange, it also serves the immunological, nutritional functions during, and also delivers growth factors and other hormones for the proper growth and development of the fetus. Placenta is the barrier between the mother and the fetus. Okay, it is a firm barrier which is well accepted by the mother during the fetal life. It is the placenta that takes care of the growth of the fetus, providing required elements like oxygen for adequate growth of the baby. It acts as a fetal lung, chorionic villi as alveoli for gaseous exchange. Placenta receives the deoxygenated blood through umbilical arteries, which are the branches of the internal iliac arteries. Transfer of nutrients and other essential elements takes place across the placenta from the mother to the fetus. And after oxygenation, the blood from the placenta is taken by the umbilical vein to supply the fetal circulation. Well, this I already told you before. Superior vena cava carries the poorly oxygenated blood from the head and neck and upper extremities, empties into the right atrium, which in turn flows into the right ventricle. Oxygen saturation in the superior vena cava blood is around 40%. Okay. Most of the right ventricle blood, that is more than 55% of the combined ventricular output, flows into the aorta through the ductus arteriosus, bypassing the non-functional lungs. The mixed poorly oxygenated blood reaches the placenta through the umbilical arteries, the branches of the internal arteries. Thus, the lower extremities are supplied by the blood with relatively low oxygen saturation. So, after birth, there are some changes because the circulation should suit to the life after birth. The foramen ovale, it closes, and the remnant of which is remained as the fossa ovalis. If it does not close properly, you will get a patent foramen ovale or atrial septal defect, which is common at the site of fossa ovalis. Ductus arteriosus remains at the ligamentum arteriosus. Well, ductus venosus remains at the ligamentum venosus. The umbilical arteries remains at the umbilical ligaments. Okay, these are the few important points you have to remember. Umbilical ligaments are the distal umbilical arteries. Fossa ovalis is the remnant of foramen ovale. Ligamentum arteriosus is the remnant of ductus arteriosus. Then extrahepatic left branch of the umbilical vein is the remnant, and the remnant of which is the ligamentum teres. Okay, these are some of the remnants of the fetal circulation. Hope you could understand the contents of the fetal circulation and its importance, right? We were fetuses before our birth. We survived based on this particular fetal circulation. So we are happy living creatures now because of the presence of the functional placenta and the fetal circulation that has provided us with the adequate oxygenated blood and the nutrients. So we have grown adequately well, and our parents given birth to us. We survived to this level, and thank you very much for the fetal circulation, and hope you have enjoyed the lecture. Thank you for patient listening, and we'll meet you again in the next class. Until that time, bye-bye. We'll see you in the next class.